And it's good morning from me, and it's good morning
From me! From him!
from him. Hello, everybody. Yes, viva la eagle, Sion. Viva la eagle. Okay. Both Mitch and I are probably a little bit twirly in the brain today. We don't know where this is going to go. So I've got to get the important thing out of the way first. I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to the elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. Because after this moment, it could go anywhere. Derailed in the first 30 seconds. Jumping across to...
Could even go to board design, John.
It could go to board design. That would be incredible. Let's see if I can, hang on, zoom out on that so that I can see more of them. So, Any Mules is here, and Cable Tie. Cable Tie, I haven't seen you for a while. Miss you, Cable Tie. Holy Flame. Oh, Holy Flame, I think was here last week or the week before for the first time that I saw anyway in the chat. Jax Tech, John Whips, Justin Spencer. Keen is here. G'day, Keen. Marty Smith, Mike Carden up in Canberra. Mr. Fixit, Chip is here. I've got to get out of the habit, Chip. I know I still have this habit of calling you Chip because that's what we called you at school, and I will try to reassociate the name. So Crispian. Pancake Legend is here. Hey Andrew. Scott Miller, some call it fun. Steve the Squirrel is here. Tassie Bob, Delane, Sion giving us, yes, revving us up about Eagle, Wagon Loads. Amanda is here. David, Iggy, I haven't seen you for a little while either. Rob V, Russell, Stephen W and Stephen George. Sharky, Imi is here. Jordan is here. So there are lots of people in the chat already. Now, Jordan says, hey, I'm close to on time for once. Tom, you're here as well. Hey, Tom. Now, what was in the chat earlier? Did you get all your nuts? Asked Stephen. I don't know. So Crispian said, I'm interested to see what this live PCB will look like when it is done. Okay, now, last week, I thought that we would end the stream with a completely routed PCB. We didn't. I don't think I did a single trace. Yeah, it's entirely my fault. It's not Mitch's fault at all. I did not route a single trace last week, despite having an entire 2 hours to do it in. So this week we are going to try to get to the point of having a routed PCB and ideally generate some production files. So that's the goal. Scott said the time is now 16:05. Do you know where your squirrels are? 16:05? What time zone are you in, Scott? Okay. Where to begin? All right, now one important thing. Big news. It finally happened. KiCAD 8 has been released. Yay! So, yeah, we need the streamers for that. So I have KiCAD 8 installed. I just installed it right before the stream. I haven't, apart from opening the control panel, I haven't opened anything yet. I haven't opened the project we were looking at. So it probably hasn't deviated very much from release candidate 3, which I was running last week, but now it is official. So missed the 8 and hit the 6. Okay, so it's 18:05 where you are.
Pacific Standard Time, I'd reckon.
Okay.
So, John, it's
yes.
KiCAD 8 has that new software spell.
Oh, yes. Haven't even driven it out of the dealership yet. It's still brand new. So it's going to depreciate in value in the next half hour as we start using it.
If we were Asians, we'd leave the plastic on the seats.
Yes. Preserves the value. So, Eastern Time, says Scott. Right. Okay, so I don't even know where to begin with this, but there are a couple of interesting things that we can cover this week. Oh, I just noticed this audio is very high. I'm going to turn it down 2 notches. Hopefully that will be about the right audio level.
How's it sounding out there, folks?
Yes, some feedback please. So Iggy says, I'm in flat cam preparing for my first double-sided milling job at home, so it seems like a natural progression of what is happening here. Double-sided milling job? As in milling a PCB? Is that what you're milling? That would be interesting. Screech. Okay, audio good, says Amanda. Now, PCB, yes. Ooh, that's cool, Iggy.
How do you get the registration? That's
I know, yes,
yeah.
when you flip it over, doing it double-sided. Do you pre-drill the holes? That was what I always used to do. When I was using, yeah, we're off on a squirrel, 1/8 pins. Oh, okay, so you've got alignment pins. That's cool. Yeah, when I was doing my first double-sided PCBs using resist pens on the copper, I used to overlay the design onto the PCB first, mark all the holes and drill the holes, and then use those as reference points. So hand draw the design on one side by joining the holes up and then turn it over and then join the holes on the other side. Yeah, registration on double-sided PCBs can be a pain if you're doing it yourself. Anyway, here I am chasing a squirrel. So there are a couple of things that we can cover. Somewhere here, somewhere that you can't see. Here we go. I will just bring this up. Come on.
Tear off the tab.
Tear off the tab. I can't grab the tab. Here we go. This is the KiCAD 8 release announcement. So it's got some information here about changes to 8 compared to 7, including improvements to the KiCAD libraries. So if you are updating, because I'm actually in a really good position here because I don't have any previous investment in custom libraries or anything like that. I am starting from zero. I've got no legacy KiCAD installation other than what I've been messing around with over the last few weeks.
You need Steve to say PCB reminder every 15 minutes long.
Yes, I do. And so
I've got a soldering iron. I can.
yes, you can wake me up. Yeah, so I can just grab the latest installation, latest libraries, and get everything, which is nice. Expanded support for importing data from other tools. Very good. So bringing it in from Easy EDA, CADStar, SolidWorks, Altium Designer, Eagle Symbol Libraries, LT Spice Schematics. So it's gained quite a few import features. The PCB editor also got a new shape healing feature, fix up small gaps between line segments.
Very useful when you haven't connected the segments of your board outline, for example.
Mm-hmm. Yep. New possibilities for data export. I'm not going to go through all of this in detail. I'm just pointing out that 8 is a big new release. It's got lots of cool stuff in it. So it looks like a lot of these changes are going to make life a lot easier. Improvements to the command line interface. That's interesting. So one of the things that I have found to be incredibly powerful about first Eagle and now Fusion is its command line interface, because it allows me to do things like use the Stream Deck to do arbitrary actions within Fusion just by pressing one button. So being able to send command line input to the program to make it do different things is a really good way of streamlining workflow. If there are certain actions that you take, you can, in Fusion for example, you can set up macros and have it execute a series of actions just by pressing a button and sending a command line to it. And being able to do that sort of thing in KiCAD is very, very useful as well. So you can see here that there are a number of new things that can be done through the command line interface. Some of these are things that you would only do rarely, like changing the order of layers in multi-layer board plots. But just having the ability to control functions within the program from text input is very, very useful.
Could be wrong here, but I think there's two command lines here. The first is that you can start a Python shell inside of KiCAD and do scripting kind of things. I think what they mean by command line interface there is if you run KiCAD in a terminal, then you can do things like export to PDF and those kind of things from outside of KiCAD, which would be useful, for example, if you need to kind of automate your production process, especially CI kind of activities.
Yes, and there are a couple of good examples of that. So those are really two different contexts. One is you are the one that Mitch is just referring to there, if I understand it correctly, is using KiCAD as a tool as part of another workflow and calling it to execute actions. What I was talking about a moment ago was more when you're using KiCAD in an interactive mode and being able to send it commands or select tools or do things like that. So with this you can do things like generate a bill of materials and generate 3D models. So a lot of these sorts of things could be, for example, called on Git commit hooks, so that if you wanted to do a release of your project, you could have a script call KiCAD to generate the bill of materials automatically or generate a 3D model at that point in time. So there are lots of things that you could do with that.
Let's say you get an order for 50 boards. This lets you export the bill of materials so that you could then import into something else that would place the order for you.
Yep. Other smaller KiCAD-wide changes, an alternate second hotkey can be assigned to any action. That is actually potentially extremely useful. It's one of those things where, now I'm trying to remember what it was, but just a week or so ago when I was playing around with KiCAD, there was a situation where I wanted to assign a second hotkey and I couldn't do it. This was fairly recently. I was experimenting with it. Anyway, it's totally gone out of my head now, but being able to have multiple hotkeys assigned to a single action in a piece of software can be very, very useful. It may be that you want a hotkey that you use when you're operating on it in interactive mode just on the keyboard, but you want to be able to send a different command from some other device like a Stream Deck to execute the same action. So yeah, that's a bit of an odd one, but that can be useful. Library editors now show a small preview of symbols and footprints when hovering over their names in the library lists. I think we saw that previously when we were experimenting with it on a previous stream. New UI for properties, net navigation and search.
So the idea of net navigation,
Net navigation?
I'm not sure about that, Sion. I don't remember clicking on a pad to start it with X. I think you can just hover over and do X. But let's have a look at that when we start it up. So previously, for example, if you had a design that was over multiple sheets and you had a net that was in multiple sheets, it was hard to find out all the occurrences of where that net was in the multiple sheets. Now you can click on a net, and I think under the view menu you can bring up a browser there that shows where that net exists in all the different sheets that you have. There's also, as we can see on the screen, there has a properties window that you can quickly twiddle with things like values and stuff.
Down here on the left.
And advanced searching there. So it used to be search was a kind of little box that picked up. Now you can quickly search for things and be able to home in on there, so improved there.
New bill of materials exporter.
So it's no longer calling out to an external script. So generating the BOM is now internal to KiCAD.
Mm-hmm. Oh, export styles and presets. Interesting. Okay. Pin helpers.
Have a look at this animation.
Yes. This is doing multi-breakouts. Yes, nice. This is cool.
You can also do things like set net labels, and it will pick up those net labels based on the names of the pins. Example there.
Yeah.
So if you're dealing with buses, that could be very useful.
Yeah, I find this very useful when I'm doing an initial setup. This is a feature that I use a lot in Fusion, and when first setting up, like adding a chip, a classic example is something like an I/O expander. You plop down an I/O expander, and it might have 16 GPIOs that you want to break out, and have nice named nets. So you just select the chip. In the case of Fusion, you right-click on it, and then you can select whether you want to break out all pins or a range of pins or whatever. And the naming convention, and it does essentially the same as what you see here in KiCAD. And I found that's been a very useful feature. So having that in KiCAD is a really good thing. I'm sure that I will be using that a lot. And it's very nice the way the selection works on this. So you can't do this in Fusion as far as I know. So in this particular case, it's dragging across pins to select them, and then you can apply the action to those pins. That's a really slick and very quick way of acting on a number of pins. And without actually seeing it here in the demo, my guess is that the same selection options would apply. So if you wanted to do this to pins that were discontinuous, you could probably do a selection of multiple pins by holding Control or whatever the modifier is to select multiple pins and then applying that action to them.
There's also, if you're doing something like this, if you, for example, pulled out PA0 and then put a net label on it, if you pull all these wires out, pressing Insert will increment that number if you're doing net labels.
Mm-hmm. Yeah, so it automatically increments and everything stays nice and neat. Comparisons of symbols to library versions.
So previously it would tell you if, yeah, we're squirreling a bit. Previously it would tell you if there was a difference between the symbol that you were using and the version in the library. Now you can get a visual representation of those changes.
Oh, I see.
So as you slide left and right, it'll fade in and out the library in your version.
That is really cool. I like that.
I think there's also a tab where you can ask it to tell you the properties. So we've got summary and visual. If you were on the summary tab there, it would say this pin has changed its mode, this pin has...
Okay, now improvements to grid handling. This is interesting as well. So one of the things that after the stream last week, Mitch asked me about how in fact, I think it was last night we were talking about this. Mitch asked me what my experience was so far and my perception of how easy it is to use KiCAD compared to Fusion. And the probably the only point of friction so far is, I can demonstrate this soon when we have the PCB layout open, is the way the grid is displayed. And this, I think, is it's a rendering issue essentially. So in Fusion, if you have a grid displayed either as dots or lines, the grid is always visible and never intrusive. So as you zoom in and out, the dots will move apart or closer together, but they always stay the same size and they always stay just visible without getting in the way. And one thing I noticed in KiCAD is that the grid can be totally invisible, or it can suddenly jump into view. And it seems to be some issue with the rendering on the canvas, where however it's calculating the size of representing the grid, each grid point, is a little inconsistent. So anyway, that's just a minor thing. And the point that Mitch and I were talking about last night is how impressive it is that KiCAD will run on the three major desktop platforms, and it's pretty consistent across all of them. And the difficulty of creating software that runs on Linux, Linux first is what it was originally developed for, and also runs on Windows and Mac, and the fact that it works at all or so well across all three platforms is amazing, when they have different windowing libraries and that sort of thing. So trying to create the software that works well across all of them is it's a big challenge. So it's very impressive that it works as well as it does.
Under the hood, KiCAD uses a UI library called WX Windows. So I think the magic of making it work essentially appearing the same is in WX Windows. And I think KiCAD is perhaps the biggest user of WX Windows, or certainly the thing that pushes WX Windows the hardest. So that journey has been that Linux was done first, and then Windows have been quite good for many years, but it's really only in the last year or so that a lot of the niggles in the Mac version have been worked out, especially with things like touchpad.
Yeah. Okay, so grid options. I think we'll speed up a little bit and just sort of skip through some of these. Editable power symbols, simulation. Ooh, that is something for the future, not something for now, but it's got a whole lot of new simulation features. Multiple footprint dragging.
This is something which I think is still a bit underdone in KiCAD. If you drag those parts so it hits tracks, like if you move it to the left there, it wouldn't know what to do with the tracks on the left.
Is that because the tracks have been bounded by this other pad here, and it squeezes them?
In this case, but even if it wasn't there, it would still struggle. Okay.
Interactive length tuning patterns. We won't get into that for now. Connectivity for graphic shapes. That's
for the folks at home. That what we're seeing there are things like Wi-Fi and Bluetooth antennas on the PCB, which have to be a very specific shape.
Yes. You have to be a magician. Footprint editor properties panel. We might get into looking at footprints fairly soon. 3D viewer UI overhaul. The built-in 3D viewer in this is really cool, and the ability to have this auto update live, which I think is an option you were saying, wasn't it, Mitch? So you can either update the 3D view on demand from changes to the PCB layout, or you can have it update live.
Yeah, so usually it'll update when you mouse over the 3D window. You can set it so it does a live update. So it doesn't have the kind of multi-second push thing in Fusion, which can break your flow. The big change here is to be able to turn on and off particular layers on the right-hand side. Previously in KiCAD 7, you could just do some of the things like turning off through-hole models, surface mount models, but here you get control over the layers and opacity and a bunch of other things. We'll see that later today.
Yeah.
No, really, we will.
We will.
And KiCAD 7.0.11 has been released, so KiCAD 7 is in bug fix mode. It's now that 8 has been released, this is expected to be the last 7.0 release that will be made, because all the development effort will now go into 8.
Yeah. There was sorry, I'm distracted because I was just looking for a tab. I have many tabs open, unfortunately. There was a tab that I've had open with a KiCAD.
Do you know you can search for tabs?
I don't even know what I would search for. Oh, here we go. Yes. Okay, this is just something that we will probably bring up later. I'm not sure if we'll talk about it today, but I saw an example of a KiCAD footprint for a Raspberry Pi Pico, and I thought it was very interesting the way that it was presented. It seemed to be very comprehensive with the schematic symbol, the footprint, and the 3D model and multiple versions and very well documented, but we'll get to that. So at some point we'll do something, we'll probably do things like install third-party footprints, so we'll get back there.
I'm going to answer Wagonload's question about creating pad spacing for edge connectors. There's a technique that I often use. Let's say that you have 20 things in a row. If you know the difference between the first and last pad, you can set the distance between those, and then all of the other 18 things in between that, you can say equally space these 18 between the first and last one. That's a way that you can get evenly spaced stuff for a particular pitch.
Yeah, okay, so lots of fun stuff in KiCAD 8. I'm going to close that off, and we should probably jump in here, shouldn't we? So
yeah.
Okay, so opening the board layout and where we got to last week. So where we ended up was just the parts plonked down after syncing them across from the schematic, and then putting an outline for the board dimension. So at the moment we're on the edge cuts layer, and that is this outline right here. And so what you can see here, I don't know how well this comes through on the stream because of video scaling and all of those sorts of things, but this is where the grid issue comes in. So as I'm zooming in and out, like if I zoom out there, the grid vanishes, then it suddenly appears, and then as I zoom in, it gets fainter and fainter, and then I zoom right in here, and then it pretty much disappears again, apart from the major dots. So this is, oh, and then suddenly it's jumped to a different scale, and then it fades out again. So as you're zooming in and out, the grid sort of keeps appearing and disappearing and becoming more obvious and less obvious. That was just the weird thing that I noticed when I was playing around with it last week.
My guess is that there is a rationale there, it's just that we don't understand what the rationale is, rather than it being something they haven't done.
Yeah. Okay. Gavin? A trip to Bunnings. Okay. Sorry, I got distracted. Gavin has been on a trip to Bunnings, which for everybody outside of Australia is a big hardware chain. Probably like Lowe's or something in the US.
Home Depot.
Home Depot, yeah. So Home Depot, you should say. All right, so I'm going to continue my my role of asking silly questions so that Mitch can explain things.
John, I've got a question. I'm
Yes.
thinking of the original Funway layout.
Yes.
For this board. How do we want to be guided by that original layout? Are we going to go for something that makes sense to us, or be inspired by the original one? Is it, if we look at the original one, did they have a way of doing layout that is particularly sensible that we can steal?
That is an excellent question, and I'm just going to open Funway Volume 2 so that we can have a look at how this was done in the original. So this is, I'll skip through all of the intro stuff here, assembly tips, looking for the, here we go. So this is the project that we are converting at the moment. And there's a photo of an assembled circuit board. And down here, we can see the physical layout of the board, and we can see the schematic. So what I'm going to do is zoom this in and stick it up on the right hand side so that we can see it while we are doing our version of the board. So there are a couple of things to consider here. And then I'll move that over there, and hopefully, yeah, the relevant parts can be visible as we're looking at them. So, okay, near the end of last week, we were, or was it the week before, I can't remember, we were talking about putting a ground symbol on the schematic. Now if I come back to, is this the schematic link? Wait for the tool.
No, I don't think so. I usually just Option tab.
Oh, okay. Schematic. Here we go. So I was talking about whether I should place a ground symbol. Oh, that's right, there are the different net classes that we were messing around with. Let's get all of this into the useful spot. Now, I have put a fair bit of thought into this, but it doesn't necessarily mean my thoughts are clear. One of the things that I found really interesting about Funway Volume 1 is the use of the paper overlays and then putting the parts directly on the paper. And what that meant is that there was a direct one-to-one correlation between the layout of the schematic and the layout of the parts. So you could very easily see, so what would happen if this was being done in the Funway Volume 1 is the paper would represent the schematic like this, and it would have the positions for the part. So you would put the part physically over that location on the schematic. And just for me and the way, I suppose the way I think about things, I found that very useful early on. I wasn't even aware that it was happening because I didn't have the context, I didn't have any of the experience. But now in retrospect, I can look back at that, and I now understand that in my very early stages of getting started with electronics, that was one of the key things where it allowed me to mentally map the physical parts to the schematic and show that the two are the same. Because in a lot of projects, if you look at the schematic and the PCB layout side by side, it's not really obvious that the two are related. You could have a schematic and a PCB side by side, and they could be different projects. And you could, at first glance, you might think, oh yeah, that one is the same as that. So having that very strong correlation is useful in terms of making that mental jump of, I have designed the circuit to operate in this way, and now I'm going to have a physical implementation of that circuit. However, there also comes a time when you need to abstract the physical representation from the schematic. And the schematic is intended to be an abstraction. It's meant to show the functionality and not how you have physically put that together.
So the schematic shows relationships and behavior and conceptual kind of ideas, functional block kind of things, so that you get an idea of what the circuit's trying to do, but it doesn't say how the circuit does it.
That's right.
Or how that's implemented.
Yes. And this circuit could be implemented on strip board, or it could be dead bugged with just wiring resistors together and stuck out in the air. It could be in a breadboard, it could be on a PCB. So the physical shape of it could be absolutely nothing like the schematic. And that is an important concept to get across. So what I'm really, this little tangent that I'm going off on here is a kind of a question about philosophically, what is the purpose of this project? And what is the purpose of making boards to match the Funway projects? So to me, it's about getting people into it and teaching them some basics, the sorts of things that that I wish I'd had. So you can see here, for example, the physical layout of the schematic here and the PCB do not exactly match. They're kind of similar, but they're not identical.
I'm looking at the position of R2 and R3 on the schematic and R2 and R3 on the board. Mm-hmm. They've jumped sides.
R3, so that's R2 going to the LED, which is on here.
It's R3.
Oh, that one is R1, sorry, going to the LED. So I think that's, oh no, that's R1. Oh, it loops underneath, I see. Yeah, it's a little bit hard to see, but the trace is in
so
faint
on the
grey.
schematic, from left to right, it's R1, R2, R3, R4.
Yeah.
And on the board layout, it's R1, R3,
R2, R4. Yeah. C1 and C2 are in the same order, and the transistors are in the same position, but you can see that one of them has been mirrored. Whoops. One of them has been mirrored on the schematic for the sake of neat traces, and on the PCB there is a trace that runs underneath the transistor. Just because you can't physically mirror things like that in the real world like you can on a schematic. So one thing that I'd had in mind was, so this is a decision that needs to be made. I thought that it would be interesting to do the board layout and then put silkscreen over it to show the positions of the tracks. When typically if you do a single-sided board, the tracks will be on the back of the PCB, not on the front. So if this is all done as a single-sided PCB, oh, and that is another decision. Do we deliberately go for a single-sided PCB for simple, to make it conceptually simple, or do we use two sides?
Once upon a time we did single-sided because anything other than that for hobbyist stuff was prohibitively expensive. Also, practically at home, we could only really produce single-sided home etch boards.
That's right. So unless you're Iggy with a mill, we're not really dealing with that so much anymore because it's so cheap to have PCBs produced in double-sided and with silkscreen and solder mask and all of those sorts of things.
Been wondering, John, for a couple of weeks now what the purpose of the link is.
This link
Yeah.
is where a second LED would go. So that, up here, you can have a second LED with R4. So what you would probably do is change R4 to be 330 ohm.
Oh, I can see the text there, just the text below it.
See text.
I know, here.
Yeah. Oh, yes. We've shown a basic 1 LED design, but you can do it with 2. Yeah, so then the LEDs just alternate. One is on while the other is off. Okay, the question is, do we want to implement that as well? It's amazing how with what I thought was going to be a simple project to get started with, there are all these design considerations we have to think about. So do we want to support the second LED? I hadn't even thought about that. That hadn't crossed my mind. Yeah.
Another thing I'm looking at here is a technique that is often used in single-sided boards, and that is running tracks under components. So if you look at the resistors there's quite a distance between the pins. That's an opportunity to run tracks between them. On fine pitch surface mount boards you often don't get the chance to run tracks between them, so we would then use the second layer.
Oh, and okay, here's another curly one to throw out. This is something that I just mentioned to Mitch last night. One of my ideas for this was to have 2 different versions of the board, one as through hole and one as surface mount, because I want to give people the opportunity to assemble a surface mount kit and learn those techniques. So what we could do is have a version which has regular 1/4 watt through hole resistors, as we see here in the original design, and another one that has large resistors like 0805 or even bigger, with slightly oversized pads to make it easier for hand soldering. And that way people can have a relatively simple kit to assemble that does something. There are quite a few learn to solder kits out there already. There are some quite cool ones around. So John Spencer from the Connected Community Hackerspace has done a couple over the years. He did a little solder rocket kit and some other things. And yeah, I just like the idea of having the same schematic. So what we could do is have this identical schematic that has 2 different embodiments, one with through-hole parts and one with surface mount parts.
John, I have the view, which might be a bit controversial, that as long as the parts are appropriately sized, I think for beginners surface mount soldering is easier to do than through-hole. I'm wondering what people listening to the stream think.
Yeah. Oh, Scott pointed out that in KiCAD, many or most of the built-in SMD footprints have hand solder versions. That's right. So there are multiple footprints. There is, I think, on most of them there are three. There's a regular size, there is a tight fit, so it's a smaller pad, and there is an oversize, which is easier for hand soldering. Yeah, and sorry, that totally. That's right. You're talking about the ease of surface mount assembly. I personally think surface mount is easier and quicker than doing through hole as well. So I agree with what you're saying, and I think part of this is overcoming the perception that surface mount is harder, and being able to offer a fairly simple kit that can be done as either through hole or surface mount means that if people want to experiment with learning how to do surface mount soldering, it's an easy, cheap introduction to it, like a basic kit that might cost $10 and has all the parts you need and nice clear instructions, and it's specifically laid out with plenty of space so that it's not too intimidating, it's easy to get started with. I think is a good way of showing people that it is quite easy to do surface mount soldering.
People starting soldering often haven't yet developed the ability to regulate the amount of heat that goes into the board, so it's very easy to put too much heat onto a pad and lift a pad off the board. So if you can design it with kind of oversized pads that are quite capable of taking some beginner treatment, well, that means that they're not going to end up with something that dies.
Yep.
I reckon, John, we just
do
the layout just as it is
routing
there.
Yeah, okay. So reproduce this to some extent. So
those nice artistic curved tracks.
Yes.
KiCAD does support. So generally you put in the tracks in the non-curved function and then say, dear KiCAD, please make all this curved with teardrops and stuff.
Ooh, okay, so I'm going to do, if I do G for drag, no, I can't do that. How do I move this to adjust the dimensions?
I think this is not very well done in KiCAD. I think it'll be either M, you may be able to get away with doing a D for drag.
D for drag, okay. I just did, what happened just then is I moved over it, I pressed M for move, and it's highlighted the cursor, including the crosshairs, and I suspect that that line is actually vanished, like it's hiding in that vertical crosshair, so we can't see where it begins and ends. If I click here and put it down, yeah, there it is. Now we can see it again.
What I would do is click on the top line and adjust the length numerically, and then reconnect the side lines to that.
Adjust the length of this one.
Yeah, so I'd press E for edit.
Yep. Just before we do that, I just want to try a couple of different techniques. So that clicking on it has shown nodes on the end. If I just click and drag that, okay, so I can move the node.
Yep.
And it leaves the other one in place.
Yep. So it'll snap to existing things there, not just to the grid.
Yeah. So if I do G for drag, which is what we would do in the schematic.
G for dragging, it's a little bit inconsistent. G is dragging in the schematic editor,
but not in,
because D is for datasheet.
Right.
So in the PCB editor, you've got M for move, and for the push and shove routing, it's D.
D for drag. Yeah. So I'm curious to know if that works on this, but it looks like it doesn't. I can just grab it and move it, but oh, now I've got to move it up a bit on the grid. Okay.
This is an example here.
Ooh, look, it hasn't quite matched.
Yeah. So I would.
It's off grid now.
Click
So
on
I'm just
one
going
end and rely on the snapping to join onto the other.
Oh, I just hit undo a couple of times.
I wonder if Xeon has a more saner way of doing this. We'll see. We'll see.
Yeah.
What
okay.
were
Some
you
call it
thinking?
fun. Just pointed out. Just note that R1 to R4 are not in the same order as the schematic on the Funway board layout.
Yeah.
And Wagonload says, I recreated the circuit you were showing on KiCAD and got everything you have to fit inside a 14mm circle.
Nice.
Cool.
Yep. I suspect one of the reasons why they swapped the resistors over is to avoid that crossover that we can see in the schematic, which is going to be difficult to do on a single layer board if you're not using a link.
Yeah. Okay. So actually, I'm just going to go back to. Oops, no, that was not what I intended to click. So we've got R1, R2, R3, R4. We are matching the schematic. I just wanted to check whether our designators match the schematic designators, which they do, I believe. So
John, I'm going to muddy the waters again here.
Yeah.
You mentioned Funway 1 with the chipboard and the screws and the paper overlay, that the physical layout would match the schematic. In terms of somebody who this might be the first project they've ever done, for this one, what we can do with a two-layer board is have the layout match the schematic, because we can put vias in. So do we want to adopt the original layout, or do we want to go with the Funway thing and reduce the cognitive load of somebody who's looking at this for the first time?
I quite like the idea of matching the schematic. So in that particular case, on the schematic here, you can see that there is the little loop, which is the old style way of doing unconnected nets. We don't have that in our schematic, but what we could do on the PCB is have a via come up to the top of the board, run across, and then a via back down again. So we are recreating physically this representation that is on the schematic. Yeah, I kind of like that idea. Sion said something about the edges. He said, I turn off constraints, shift space, and then click ends and drag for snapping. Okay. So in that particular case, say I've dragged this off and I've screwed it up. So turn off constraints, so shift space, and then grab the end. Oops. And oh, okay. It's I don't think I did turn off constraints. I think I had constraints turned off already, so I've just turned them on. So if I do shift space again, now I should be able to drag that and have it snap. Yep.
So that circle it's telling you I'm snapping to an existing thing rather than the grid.
Yeah.
If you've got something that's very, very nearly on the grid, then that can make a big difference.
Yeah. So in that case, it is snapping to it, and the circle shows that we are snapping to it.
Holy flame, or use a wire link from cutting resistors.
Yes. Oh yeah, so what Mitch was just responding to was Holy Flame said, to avoid a via, you can also add a 0 ohm resistor and route the other trace from under it. That's right. So using a 0 ohm resistor is a good trick for that sort of thing. Wagon Load says you can make the red line go under C1 and R2 without using vias. Yeah. Okay. So let's
very good idea.
Let's just start laying stuff out, rearranging it into the representation that kind of matches the schematic, and we'll see how we go from there. Now, one question, something that I have noticed. This is about the 0 point of the origin. My question is, where is the origin point for coordinates in this, given that all I did was plonk parts down and draw a box around them? If I export this, for example, for Gerbers or for a pick and place placements, which shows the coordinates of each of the parts, there needs to be a 0 point that everything is relative to. So in Fusion, what I normally do is lay out the bottom left corner as the 0 point on the grid, because Fusion has an X and Y axes with a specific 0 point. And my very vague understanding is that KiCAD does it in a bit more of a user-definable way, like you can define what your origin is. So when I'm starting a new project like this in Fusion, I would start from the bottom left corner being 0, 0. What is the best practice approach in KiCAD for
Unexpected maker
thinking
said
about
you
this?
must go to settings, origin, axis, and change origin to be drill position and Y goes up. I hate the defaults.
So yes, by default, 0, 0 is in the top left-hand corner. You can change that also the Y increment. So Y goes positive is down, whereas most people you want positive to be up.
Right.
If you wanted to assembly at JLC, for example, they expect your 0, 0 point to be in the bottom left of the board.
Yeah.
As Sion is saying there, you can go into settings and change this here. I think you can also press S to place the origin on the board.
Okay, so if I wanted the origin to be here,
Yep.
and I just pressed S,
I'm not sure.
I don't
Maybe
know
it's
what
not
that did.
S. There's something on the right-hand side there towards the bottom.
Yeah. Also,
Might be that arrow with the
Oh.
X on it,
like-
on the right.
oh, on the right.
Yeah.
That one, delete clicked items, no.
Try going down.
Place the grid on, place the grid origin point, this is it. So we want I want to select the origin point as being there, and as you can see by the circle coming up, it is snapping to that point, which is perfect. So,
So on the status bar at the bottom, you can see the current coordinates.
Yes.
Let's see what happens when we click on that.
all right, so at the moment it's saying X is 81.5, Y is 120. If I click on this, it should reset. Oh, it hasn't reset 0. So I have set
Maybe this is for generated files.
Yeah, okay.
I'm going to mention in passing here that if you press space, it'll temporarily set coordinates. So there's an X and a Y there. There's also a DX and a DY. So space
delta.
is where
Yep.
you can set the origin for that.
Right, so if I wanted, for example, to know the distance between
Unexpected
these...
Maker said click and hold that icon, and then use the Alt icon.
Oh, okay. I'll do that in just a second. So what I could do is go to the center of this resistor, click space. That resets the 0 point for the temporary origin. I move to the second one, and now it's showing we've got a delta Y of 4 millimeters, delta X of 0. So they're vertically aligned, but they're 4 millimeters center to center. So that's an interesting, useful tool. That's a good way of measuring things. So Sion was just saying, click and hold the icon, and then use the Alt icon. So this one here, I'm going to click and hold, and then it's got a second icon here. I'll select that, if it'll let me. Will it? No? Why can't I select that? I'm trying to click it and it won't do anything.
There may be an option under place up the top.
Okay. Under place. Is that, Dodgy said, is that a bit like a work offset? Yeah, I think it would be. It's like setting a temporary origin and working relative to that. Oh, you have to be on the board edge. Okay, so if I put the cursor on there and then select this, it's like I can't select that tool. Maybe I'm not meant to.
I think we should move on.
Yeah. Okay, so what I would like to do though before we move on is follow Sion's advice back here, because PCB editor origins and axes, x-axis increases right, which is what I want, and y-axis I want to increase up.
I'm just going to mention here that if you're sharing your designs on GitHub or something like that, when people download your board files, they may be very confused when the coordinates go the other way around to what they expect. I don't know whether this is something that travels with the board or is part of the settings.
Okay, interesting. So it could be settings globally for KiCAD. Yeah, it may not be saved within the board. But yeah, for me, because of the way OpenPNP works, I want all of my coordinates to be positive in the up and right directions. So I think I'm going to risk it and go with this, which I think is what Sion was. Oh, okay. I had that issue on my stream 2 weeks ago. Oh, Sion just pointed out there might be an issue with that.
That's a bit magic.
It is a bit magic. So if I select the front copper layer and then long click on this.
Unexpected Maker said this is 100% needed for PNP, Y up and must be set to drill axis, but board.
Yeah. Y up. It must be set as drill axis. Yeah. This is one thing that I've noticed in the past. So I've been peripherally involved with a few projects over the years that have been done in KiCAD. And so there have been quite a few times when other people have shared KiCAD projects with me. And one thing that I've noticed is that the coordinates are often all over the place. Like the origin might be somewhere, some random location, I remember having this issue a few years ago when we were assembling boards for one of the Open Hardware mini-confs, and it was a design done by one of the other people at the Hackerspace. And when we brought the position files in so that I could assemble the boards on Mickle Make It, on my homemade pick and place machine, it really threw me because there wasn't a 0 in the bottom left corner. And I think I ended up pulling the file into a spreadsheet and reversing all the coordinates because all of the placements were mirrored. Yeah, it was a real pain. So I definitely want it to be positive up and right, so I don't have to do that sort of manipulation in future. Okay,
I
so
think
we should start moving parts.
I think we should consider doing an undo so that origin disappears.
Okay, let's do that. There we go.
In terms of just in terms of workflow, when you've got all these parts that have come across from the schematic, and you kind of tease them and roughly put them in place, there's two things that I'd suggest. The first is you tend to kind of mouse over a component and then do combinations of M and R to move and rotate. The other thing is it's useful to have the schematic open next to the PCB so that you can see the connection between the two, get an idea of which one that you're actually clicking on. For that, in terms of screen real estate, we may be able to turn off what's called the appearance manager there on the right hand side, and you do that by down the left hand side there's a bunch of icons, and I think it's the second last one will turn off the appearance. That'll give us a bit more space so that we can fit the schematic in next to it.
Okay, cool. So we can either work from having this schematic visible, or we could try to squash this in and no, not update. I've got to, oh, this one. So if I move this over here, zoom out just a fraction, we should be able to get that up to where it's visible.
You can also turn off those side things in the schematic.
In the schematic, yeah. But we'll just have it in the background, so it's going to be hidden anyway. All right, so we now have, if I select R1 in here, we can see that it's highlighted automatically over there. And then I can just grab these and drag them around. So, oops, nope. And R, where is R? I think I just locked it automatically. I just locked it because I hit L instead of R.
Undo is your friend.
Undo. Okay, so I want to do R, and I think I want to rotate all of these.
By default, if you've locked a component, you then can't select it. I'll show you in a little bit how to handle that.
Okay. Oh, I got to select. I got to click a couple of times. That's just a user interface thing. So what I was just trying to do then was
System
move this part
1 hour remaining.
by just clicking on it and dragging. But of course what that does is it brings up the marquee for group selection, whereas if you click on it once to select it and then click again, you can drag it anywhere. Alright, so that's just something I have to get used to. So click to select and then drag. Easy.
John, you've got a split keyboard here, which means that moving the hand across to the right hand side, you've got a little bit further to travel.
Yeah, and I would use my right hand typically for that. So I have kind of made things hard for myself in this context because, firstly, because I have a split keyboard, and which means that using my left hand to select keys that my right hand would normally use is actually kind of awkward. And secondly, I'm running the Dvorak layout, which means that the keys are not in the same place as they're shown on the keyboard. So I can't just look down at the keyboard and go, ooh, there's R for rotate, because it's not there, it's in a different place. So, yes, this is something I've done to myself. So, what are we looking at here? Positive, this is actually already oriented the correct way around. And if I grab C2 and rotate that, it puts it the other way around to match what's on the schematic here. D1 is the LED, so I'll rotate that once, I think, and I'll bring it up here.
I think that, oh no. The air wire tells us
Scott
which
Miller
pin's
said,
which.
so you're not allowed to complain about anything related to hotkeys.
Exactly, Scott, because I brought it on myself. Okay, now we've got BT1, this is the battery, so this is one area where this version of the design deviates a little from the original, because on the original
Peter Muller
PCB,
said, hey folks, don't forget to dislike and unsubscribe.
that's it, unsubscribe please. What is, oh, okay, I was trying to select the whole part and it was selecting the center pad. Q1 comes over here, and which way are we wanting to rotate that? I think we want it to go that way, but that is open to changing later. Alright, so I'm just ignoring the board bounds at the moment. No, I'm going to move this up here because I want a representation of this is going to end up being a bit of a mess, isn't it? Anyway, I will figure this out. I'll learn ways to do this.
Physically, how big do you want the board to be? Like,
Yeah.
if we kind of...
Well, the original was designed to fit a specific style of plastic project box called a
Jiffy box.
Yeah.
Yes.
The UB5 size or UB3 size, I can't remember. It's only been decades. So on the original, there was a single hole at the top of the PCB for the positive side of the battery connector and a single hole at the bottom for the negative side. With this, what we've got is a 2-pin header where a battery connector could be soldered on, which I think is okay. They can just go on the side like that.
Into the hole.
Yes. Alright, so we have approximately the parts in the same order as they were before. So when
So around about now, I would do some alignment stuff, which we look at. Maybe that's what we can do with the resistors.
okay,
So if you rubber band all those there, and I do it with the right mouse button. I don't know what you've got there. So let's have a look at the align distribute.
align
options.
distribute down here. So we've got distribute horizontally, distribute vertically. There are some interesting ones here as well, align to left, align to right, etc.
Yep.
So if we do distribute horizontally, what that has done has it's kept the position of the first and the last parts, and it has moved the intermediate parts to make all of these gaps the same. So if
Typically what I would do is, for example, click on R4. If I wanted a particular spacing, I'd click on R4, have a look at the right mouse button, and there's positioning tools.
Positioning tools there, yep.
Move with reference. So click on R1 there.
Oh, okay. So in the center point of R1, yep.
I suspect this is not what I was after. Maybe move exactly or something.
Okay. Now this is interesting though, because you can see that my cursor is offset against this one. So if I wanted to make this spacing to the LED relatively the same as this is a way of like transferring a spacing from one part to another. That's quite cool. Okay, so let's right click on this and try positioning tools, move
Position relative to...
Position relative
I think
to...
the order might be different on my version.
Okay, and then if I click R1...
There's a dialog box that's just come up, which
Right.
you can move on screen. There's a button there, Select Item.
Select Item.
In this case, I think because we start on R1, let's
it's-
click on R4.
Yep.
Okay, and then we can specify the offset X and the offset Y. So if we wanted to be 6 centimeters between R1 and R4, that's where we, yeah.
Yep, and 0 on Y.
Yep.
If I hit OK, it has now moved it and put it right out here. So if I now, just out of curiosity, I'm going to move my cursor over the center of R1, press space, and then move, so that has zeroed the, right down the bottom of the screen, I don't know if you can see it, there is DX and DY, which is currently 0. If I move it over the center here, you can see now DX is 89 millimeters, distance is 89.5. So that's interesting.
I suspect it's because it's moved at 60 millimeters right of R4.
Yes.
The other option under Inspect up the top, Inspect All Tools, is a little ruler tool, so measure tool there.
Mm-hmm.
So you can click on the first one and then...
Ah, handy. And then I can see that that one is 29 millimeters across.
So let's set it to 30. So let's click on R4.
Click on R4.
Mm-hmm. So let's have a look at the positioning tools. Position relative to... Click on Select Item, click on R1.
Yep.
Put in an offset X of 30.
Mm-hmm.
Mm-hmm.
And then hit OK.
Yep. And then I would rubber band all 4 of those and do a distribute.
Yep. So that just moved it 1 millimeter across. So rubber band there, right click and positioning tools.
Careful with the right to left rubber banding there, because you may have picked up the board outline as well.
Yeah, I don't think I did, because I just did it from there to there, but if I do left to right, it'll only do the ones that are fully encompassed.
Yeah.
So if I go to positioning tools, and no, it wasn't positioning tools, it was align distribute horizontally, it has just adjusted the positions.
The other thing we haven't done is align them vertically.
Yep, which I think they were already, but now if I, just for the sake of the exercise, I'll select them all, go into align distribute, and then align to horizontal center or vertical center.
It's easy to get the wrong one and then have to do an undo.
Yes.
Have a look at the options either side of it. So left and right there.
Mm-hmm.
So align to left, align to right. So horizontal center will do a left to right adjustment. Mm-hmm. Whereas top and bottom, vertical center will give you an up and a down adjustment.
Okay, so I should be aligning to a vertical center here.
Yes.
I think.
Yep.
Yes.
Yippee.
Just for the fun of it, I'm going to do the other one. So positioning tool, no, align distribute. I'm going to do align to horizontal center, which should screw it up.
It's hilarious.
It's overlaid everything and put them on the same spot. So I'll undo that. All right. Yeah, these alignment tools look like they're pretty handy. If you're doing arrays of resistors or laying out other parts, being able to do this this way is a big time saver.
Yeah, if you're doing the initial layout and you've got a patch of 10, 15 surface mount resistors, this lets you rapidly get them kind of lined up and in order.
Mm-hmm. All right. Yeah, these are tools I'm going to have to dig into over time as I need them, learn more about how they work. Yeah, okay, so we've got basic layout.
Let's try rubber banding R1, R2 and C1.
Ah, I see, and then do an alignment horizontally,
Yep.
but it's going to be the vertical.
So distribute.
Align distribute, and it'll be to horizontal center.
I think it'll be distribute horizontally.
Distribute horizontal.
So it won't move R1 and R2, but it will move C1 to be at the midpoint between them.
Interesting. Yes, it did. So if my guess is it will take it based on the bounds. So if I did this and then selected those same three, it would redistribute R2
Yes.
to be in between the two. Yeah, so you need to get them to be
Yeah, roughly.
roughly in the right spot. You know, like that. So what I could do to make sure that these two are vertically aligned is select both of those, go to Align Distribute, and align to horizontal center. Nope. Align to vertical center.
I do that a lot.
Align Distribute, align to vertical center. Okay, so now we know that they are aligned, and we know that these ones are all aligned relative to each other. So what I can do is select these and do Align Distribute, distribute horizontally, which puts C1 into place, and then select these three, same thing, which will put C2 into place. Align horizontally, and now we know that this and this are all symmetrical with these parts. Now, one thing that I don't really have is a sense of scale. So my guess is that these large grid points here, so we've got the grid currently set to, oh here we go, it's currently set to 0.5 millimeters, and that, so each of these grid points is what? Because the grid changes as we zoom in and out. We're seeing different scales of the grid. So that is not 0.5 of a millimeter. Is that 0.5 of a millimeter? I'm not quite sure.
Do the measure tool.
Yeah, I'm going to change this to 1 millimeter on the grid, just to make things easier so I can get my head around how this grid is working. And if I do the measure tool, so that was where up here, inspect, measure tool, and I go from center of this one to center of that one, that's 10 millimeters. And we can see that it is offset by the same amount from that. So this is a 1 centimeter grid. Each one of these small increments is 1 millimeter. Okay.
Q1 and 2 could be aligned in a similar process.
Yes. So if I wanted to make
Or we
Q1,
could do it later, once we've got some tracks, because that would be useful as well.
Yeah, okay. Well, what I can do is, at the moment, they are not vertically aligned relative to each other. So the first thing I'm going to do is select them and go to Align Distribute, Align to, what am I doing? Align to vertical center.
Yep.
Yes. Okay. So they are now on the same horizontal line.
So the question there is it going to move Q1 or Q2? And it's what the cursor is over. When you do that, right mouse button is going to be the one that doesn't move.
Okay. So it takes that as your reference point. Yep. Wagon Loads asked, can you lock D1 and R1 as one part and center align the other resistors in the R1-D1 pair?
Yes, you could.
Okay. Wagon Loads suggest make a 1 millimeter fab line.
System notification. 45 minutes remaining.
Okay, so just, I know said we were going to do this later, but I'm going to do it now just to reinforce what I was just doing. This is the classic.
Maybe do Q1.
Yeah, reinforce your learning. So C1 is in the position that I want it to be in, and I want to align Q1 to be directly under it. So what I could do is select Q1. That's what I want to do the operation on. And was it under here? I think it might have been positioning tools, position relative to, no.
Yes.
It was? Okay, position relative to. And then I want to select the item, and I want to select the center of C1, and I want offset in X to be 0. Is this going to do what I want? I don't know. No. Why did it move it vertically when the offset in X? It should have been the offset in Y.
Because it's not a delta.
Okay.
It's relative to C1.
Mm-hmm. Okay. So if I wanted to make this vertically aligned with C1, am I following the right basic process here of selecting, where was it? Positioning tools, position relative to. Is this where I should be going?
I would do an align rather than, unless you wanted a specific offset, I would do an align.
Okay. And is that in
so
here?
for example, to
tools?
say I wanted 20 millimeters below.
Mm-hmm.
The other thing is that is it going to align it to the center of the capacitor or to pin 1 of the capacitor?
Yes. Well, when I was selecting the location, it would snap to different places. So I
Yeah.
think you could do that depending on what you click on. So, all right, positioning tools. Well, the probably the imprecise way to do this is I've selected the transistor. I can move the cursor over the center of that pin because I've got large cursors set up. No, it won't. I can't just drag it. Oh yeah, I can if I don't click and hold. So I could then move this so that the cursor is just matching over the center of the cap. Now this is assuming that things are properly on grid and yeah, it's making some assumptions, but if things are on grid, that's just a quick visual way to do it.
I've finally worked out what Stephen W. has been talking about.
Yeah?
Have a look at the designators for the transistors in the schematic.
Designators for the transistors. Q2, Q1. Oh, right. They are backwards. Right.
Which
Still has not picked up the transistors are swapped. Right.
Which brings me to a point here.
Okay.
How is Q1 and Q2 in the schematic linked to Q1 and Q2 in the PCB?
Mm-hmm.
Once upon a time it was linked using the actual designators. So in that case it would be easy enough here to just change Q1 and Q2 on the schematic, change the actual designators. These days the way it's done internally to KiCAD is there's a UUID behind the scenes.
Good.
So even if you changed Q1 and Q2 there, I think in this case what you want to do is you want to drag them and rotate them.
Mm-hmm. In the schematic?
Yeah, because otherwise what will happen if you change the designators there is that they'll then be swapped on the PCB because they're linked by the UUID internally.
Yes. To me, conceptually, that seems fine. So if I, the way I would think about this is that the layout of the PCB is being driven by the schematic. Like one leads to the other.
What did the original diagram do? Because I think in the schematic Q1 was on the left.
I think you are right. Yes, it says TR1 on the left, TR2 on the right. So the way I would think about this is if I renumber in the schematic and now they're in the wrong position in the PCB, I would just move them in the PCB.
Yeah.
So if I mouse over this, now this is the classic renumbering problem. I can't make this Q2, Q1 because there is already a Q1. At least I shouldn't be able to. I've just hit E for edit and it's got the reference of Q2. I'm just going to try this to see what happens. I'm going to make it Q1, hit OK.
Yep.
And it hasn't complained.
It would fail the ERC.
Oh, ERC, but it allows
Yep.
you to do it at this point. So I'll just go into the same here, edit this Q1 and make that Q2. And now we have Q1 and Q2. So you can see that we have Q1 and Q2 left and right on the PCB layout. And if I want to update the PCB now from the schematic,
Yep.
so I'll come back into here and there is this icon, I think, is that the one? Update PCB with changes. So I'm going to watch what happens with the transistors. It's telling us that changing the reference designator.
When it says processing symbol though, you can kind of ignore those. It's just iterating components.
Yeah.
The important stuff is then below that. So it's changing Q1 to Q2, changing Q2 to Q1, and redoing the nets.
Yeah.
What I should point out here is that there is those three options there up the top can be very, very useful. And the one here, if you did want to do it based on the designators rather than the UIDs, then that first option there is the one that you would do.
Mm-hmm.
Because that would preserve the UID, preserve the designators.
Yeah. And we can see the message here has changed. It's changed to update Q2 symbol association, and it's got the UID
So in that
from
case,
one to the other.
it's not changing the designator, it's switching the UIDs.
Yeah.
So
Okay.
that's good to go.
All right. So like this, leaving everything else, update PCB, close, and now we have Q2 on the left and Q1 on the right. So to me, conceptually, this is what makes most sense. I renumbered in the schematic, and now it has just renumbered in the PCB. So it's now up to me to take this and stick this over here, and
that other option would have meant that you didn't swap.
Yes.
But let's say these transistors, sorry, I think I just touched the microphone. Sorry, everybody who's now bleeding from the ears. So it's really up to you whether you do this update based on the UID or the designator.
Mm-hmm. Yeah. Okay. Right. What have we got here? So we've got collector at the top, base in the middle, and emitter at the bottom in both cases. Yeah, we have approximately the correct relative positions of parts now.
We're in danger of laying down some tracks, people.
Oh no!
How many weeks did this take? I was looking last night at how many weeks you were able to string out the OpenKO board.
Yes.
I think it was 6 or 7 weeks.
Interestingly, these caps are off-grid vertically, so they are halfway between. Probably because they would have been put down when the grid was originally set to 0.5 millimeters, and then I changed it to 1 millimeters. And the resistors are all on grid. The LED and the transistors are all on grid. This is off grid. So I just want to experiment with this. I've just selected it, hit E for edit, and move this back up onto screen. Positions. Oh, in fact, it's even weirder than that. It's at minus 79.225 millimeters in Y. So I'm just going to make that minus 80 just to stick it on the grid. And E.
Yeah, not sure.
All right, I'm just
What's happening with origins there? It's interesting.
Why I can't select that? Oh, now I can.
Gavin, yes and no. If you wanted to do it for making it nice to look at on the circuit board, there are ways to do it. The problem is that the KiCAD has to associate the footprint with a symbol, and it's doing that using pin numbers. In order to make it E, B, and C, you would have to change both the symbol and the footprint. What's happening, John?
Oh, that. All right, so X is at a very strange location. I have a feeling this is origin related as well. So if this is this means that these are no longer distributed between these two resistors because I've just rounded the coordinates to put them on the grid. So I'm interested with this resistor. Yeah, its Y is at minus 67.92.
We're going down a rabbit hole.
Yeah, we are. It is a rabbit hole, but
I think we should concentrate on tracks and
then
come back and fix it in post.
Yeah, okay. Yes. It is kind of fundamental. I do want to make sure that the origin is correct. It's in the bottom left at 0, 0, and everything is on grid positive from that. But I can redo it later once I figured out how origins work. So, all right, let's stick down a track. Now, my wild guess is that the shortcut is going to be R for route. Is that correct?
No, that's rotate.
Rotate. No, you're right. R for rotate. Shall I take some more guesses?
No.
No, because I won't get it?
Yes.
Okay. All right. What is the obscure shortcut for adding a trace?
There's two that you would generally use. And before we do that,
Scott Miller said anytime you just drop a part, it tends to get slightly weird positioning to 3 decimal places.
That's annoying. It should snap to the grid.
You remember we assigned net classes to all of these and,
Yes.
and track widths, all that kind of stuff. That's what's going to happen here. If we have
Right.
a look at these, just to review what we covered last week, I think that drop down in the top left for track is currently set to use net class width.
Yes.
We did define 2 others that are handy to have. So use net class width, and the little U-shaped thing beside it says whether or not it's going to use the net class width or pick up a track that's already
Inherit.
there. Exactly, that's right. So I think that's what we want. In general, to lay down a track, we would use X. And to modify existing tracks with the push and shove router, we will tend to use D.
Okay. X. I've got to. I know this is bizarre, but I seriously have to find X on my keyboard. Where is X? Yes. Okay. There is X. If I type it without thinking, then I can do it. But if I look at the keyboard, I'm screwed. Okay. So if I wanted to do so this air wire that goes from the pin on the resistor to the pin on the capacitor, I want to now route a track from here to here. So if I go over that point, my guess is that I have to start by mousing over one of the points.
Sion was opining that you couldn't just do a hover over, but I think you can. Let's see what happens.
All right, I haven't actually clicked. I'm just hovering over it. I'm going to click X, and I now have a tool. Yeah. Okay, so now if I click there, it starts. Right, so you have to click
That's
at the
a
start
surprise
point.
to me.
Interesting. So we've got, also the other thing is that we have the front copper layer selected here. So there are a couple of layers. It could have been on front copper or back copper. We're running on a 2-board stack up at the moment, and it had front copper selected by default. So it is on the front of the board.
So we're talking about 1mm tracks here, which I think is a good thing to do. Sion, let's see if there's a setting for that, because I think
Unexpected
people are
Maker
going.
said, "See, it doesn't work with X on hover anymore."
You are right again, my friend.
Yes.
So yeah, 1mm tracks are hard to melt off with a soldering iron if you haven't done soldering before.
Yes, I think making everything novelty size is very good for this board. Yeah, okay, so if I wanted to just put this track on the front of the board, all I'd have to do is click here, and that is now finished putting that track in place. So I could just go, oh, interestingly, this is showing up the
Scott
net
Miller
classes.
said, "Click to start, click to finish. Makes perfect sense."
Yeah, well, I'm just going to do a couple more just for the fun of it. And it is very quick and easy.
The net class stuff is
Yeah,
really
that's right.
kicking in there.
That's right, and this is a good demonstration of how the net classes are working, because we have used net class width.
System notification. 30 minutes remaining.
Hey, John, I want to point out that we've actually, after 3 weeks, laid a track. High five.
Hey! We have copper. So, yeah, because we have used net class width here, it has derived the net class from the schematic. And over on the right on the schematic, you can see the bright colors that I selected for those net classes, just because I wanted to make it really obvious that these two are a different class.
Scott Miller said huzzah.
Yes. Yeah, and also Scott said, click to start, click to finish makes perfect sense. Yeah, so doing this, clicking here, oh, click there, make a track, click there, make a track. I think this makes sense as well. X to select the tool, starting point. Oh, it doesn't go to there. Of course it doesn't go to there. It goes to there. And then that goes to there. Anyway, I'm going to redo a lot of this. I'm just playing around with the tool.
What happens, so we do X to lay down a track if there isn't a track there before.
Yes.
That track that comes down from the LED has some kinks in it, of course.
Yes.
So what happens if you try and drag one of those segments here? So a track is made up of segments. So there's that track there has 3 segments. What happens if you try and drag it? So you can click on a component to drag it.
Mm-hmm.
So that's kind of doing the right thing.
Yeah. Yeah. Luckily, but if I do that,
That's a move.
it's a move. So I'm going to undo that. Now, just backing up. So if I select just that segment and click, then it rubber bands and it retains the connections. If I select all 3 and then I drag this, it is moving and it's losing the connections to the end.
What I often do is I'll click on, say, that middle segment there and then press U, which will select the whole track.
Mm-hmm. Okay.
So typically what I do, and I know Unexpected Maker might do it differently, is to click on that center segment there and then do a D.
So click on the middle segment,
Mm-hmm.
D, okay. D for drag,
Yes.
is that it? Yeah. And interestingly, it's highlighted the other part of the track as well, down here.
Oh, that's to tell you that that's also included as part of the net, but it's not going to be affected by this drag.
Yep. All right. Now, I want to undo the net class assignments that were done back here. So if I go, I just want to move over this, hit E for edit. I'm totally guessing here. No, that has selected the wrong thing. What I was just trying to do was select
Unexpected Maker said yes, I do that, but don't click. Hover and press D and move. That works correctly.
Yes.
Yeah, cool. All right. Yeah. Let's just get back to this point. And
So
so hover, D for drag, and then you can move it.
Yep.
Yep.
So these two nets have a net class.
Yep.
Comes about not because we've clicked on it, but because we've named the net class, and then to say that the name is associated with the.
That's right.
So
That's how it came about. So
Yep.
can we unname the net, or
we can.
Mhm.
I think it's. I think if we might have to go up to the file menu.
Okay.
So schematic setup
Schematic setup. Yep.
and
Net classes.
net classes, and then there's net class assignments.
Okay. So we have cross and other cross assigned to power and logic. So if I wanted to delete that, it's selected. Just do delete and other cross.
Yep.
Delete. Oh, and I'll delete test as well. Oh no, my power net I'll delete. That was the other one. So test is just set to default. But does it need a pattern at all? Could this rule be deleted? So we could delete that as well.
I think so.
And that'll just return everything to
Yep.
defaults. So these particular nets are still named. So is there a way for me to remove the label from that? Can I just select the label and delete it? Well, let's try. There we go. So the label, or if I just click that and drag it, it is still associated with the net. That's interesting.
I didn't know that it would draw the wire.
I think that's a change from previous behavior, isn't it?
So that's a drag rather than a move.
Ah, okay. So if I moved over that and pressed M for move and move it away, the origin point for the label is no longer intersecting this net. So I could delete those, delete that. Yeah, so these now no longer have a different net class associated with them. And I'm curious to see what happens. Is it going to retain, because the routing action has been performed, my assumption is that it would stay the same size. So if I do an update from here, is it going to change anything? It is processing symbols. It's got adding net minus there, reconnecting, add net. All right, so we'll see what happens. Close that. And yeah, because the copper was already there, it hasn't changed it, which I think is fine, because
There's probably there's a hotkey, I think, to reset the net class, the track width that's done to the net class. I don't know what it is. Typically in this situation, and maybe this is a useful time to show it, is to do a selection just of the tracks and delete those tracks.
Yep.
So
Okay.
if we bring up the Appearance Manager on the right by clicking on that little icon down the left,
That one? No, not that one. Where was it?
second last, I think.
That one.
If you have a look right down in the bottom right-hand corner, it says Selection Filter.
Oh,
You'll
okay.
notice here that locked items is off is why you can't select something that's locked. If you do
Right.
need to select something that's locked, go turn that one off. So if you click on all items there, it'll turn everything off, and then you can then click on tracks.
Yeah.
You'll then be able to rubber band those 4 tracks there and press
Yeah.
delete without affecting everything else.
So if I drag across all of this, even though I'm dragging across parts, it's not selecting the parts.
Yep.
It's only selecting the tracks. So I could then just hit backspace and it's undone those. And now I'm going to turn all items back on,
Yep.
because I want to be able to select the pads to do the routing again. So now if I do X to select the routing tool, click
Yeah,
on there.
For some reason, we've still got the Inherit button on up the top. Yep.
Okay. So I'll turn that off and just route these tracks.
In passing, I should mention the other thing there down near the selection filter is the presets. So if we click on those,
here.
it won't be that useful here. It's often useful to go front layers and back layers.
Yeah.
I think back layers will just show us the drill holes really.
Yeah, because there's nothing else on the back of the board.
And I think it would show us the... So what happens when we select one of those is that you can see which layers are enabled higher up.
Oh, up here.
Yep.
So at the moment we have front layers selected, and it's got front copper, but nothing... Oh, yeah, it's got front adhesive, front paste, so it's all of the F dot layers are turned on, visible, and the others are turned off, and edge cuts is on. So if we go to back layers, it'll just alternate. Now it's all the B dot layers. So we'll just turn on all layers, and we're back to where we were. Okay. So the alignment of these caps is still not right, but that's all kind of dependent on getting the origin set, so we can skip that for now.
What happens if you drag the cap?
Okay, so escape to get out of the routing tool.
Good.
And just cursor over the center of the cap and D for drag. And it's rubber banding the tracks. Oh, and interestingly, if I put it into a position where the tracks intersect, it highlights it in green. So it's...
It could do a better job of this, I reckon.
Yeah, so I'm going to hit escape. So that was D for drag. If I cursor over the center of it and do M for move, it disconnects from the track. So it's moving the part without moving anything else.
So often, because it's got that limitation on dragging things, I think that's done better in Fusion 360. Typically, if you want to move a part and you know you're going to get a bunch of green because it's going to run up against existing tracks, you would essentially pragmatically have to delete the existing tracks and then move the part and then lay them down again. It's a bit of a pain.
Yeah. Yeah. Well, I'm sure that's going to improve over time as well.
It better.
Yeah.
I'm going to stop paying the money.
Yeah, all the big bucks. Okay, I know this is a squirrel, but this is kind of, it's interesting to me at least. So, stuff everybody, I'm going to ask this question. Funding for KiCAD development. I know that it went through a really big development boost when CERN started putting effort into it and putting developers onto it. Is there a way to support the KiCAD project financially?
They initially CERN paid for 2 developers to work on it, and that's where the push and shove routing came, and a bunch of other stuff, especially the work of Tom Vlastovsky. I think CERN have wound that back a bit, but what the KiCAD project have done is that they've now got a sponsorship program, so board makers and a bunch of other people are getting on board with those sponsorships. There's also a company called KiCAD Services, where if KiCAD is not doing what you want and your organisation has the money to do this, I mean, money that you would spend on a license for a commercial software is money that you could also spend to pay KiCAD Services to work on that feature to make KiCAD exactly work how you want. And there's a whole bunch of features in KiCAD 8 that are only in 8 because other companies needed those particular things and paid KiCAD Services to implement those features, which then get rolled out to everyone. Yippee. There is a donate button on the top of the web page, but I've kind of read that they're kind of winding back on that.
Okay.
But don't let us stop you, folks.
Yeah. So what I'm just thinking about is with Octoprint, for example. I, for a long time, supported Octoprint on Patreon. I think it was Patreon that is used for that, because it's a tool that was very useful to me. Paying a small amount each month helps ensure that it continues to be developed and it gets the care that it deserves. And for something like KiCAD, I could, from my own personal point of view, I'm currently paying however much it is, like $800 a year for Fusion. I wouldn't mind paying some amount towards KiCAD as well, just to ensure that it continues getting the care that it deserves. So yeah, that's really what I was curious about, is what mechanisms there are and whether they are beneficial, like whether it really does make a difference.
Good point. There are also non-monetary ways that you can contribute, and one of those is to write documentation, to translate it into your language, to absolutely report every crash that happens. It's not usual these days, but every crash should be reported, especially if you can replicate it, and also help other people get started. The Discord that's there for support for KiCAD, I help in that. I don't have the money to pay for KiCAD support, but I consider spending my time helping people out with KiCAD in that Discord is my way of contributing.
Excellent. And in relation to bug reports, last week there was our KiCAD crashed actually when I was exiting out of it. This was after the live stream last week while Mitch was here. And I have things crash on my Mac reasonably regularly. Fusion craps out all the time. So I didn't really think all that much of it. And Mitch said, no, it's worth reporting because they really do pay attention. So I went through the bug reporting process and I got a follow-up email. I think it was about 2 hours later. So that is incredibly responsive.
That's usual. They're very, very swift to get on top of stuff.
Yeah.
Thanks, Scott.
Yeah. Yes, thanks, Scott.
System notification. 15 minutes remaining.
Okay. So Sion dropped a link in the chat to KiCAD.org just a few minutes ago. So there's lots more information there, including that donation link at the top of the page. All right. So now let's put a couple more tracks down on here, and then I want to, if we get time, I want to ask about something like a ground plane pour or a polygon pour. Yep. Not that we're necessarily going to use it for this, but it's just a generally useful thing when you're at this stage of working on a project. So what I could do is X for tracks. I can just
See,
this is an interesting question.
If the little kink is not going the way that you expect, press /.
Okay.
The
cool.
other thing is that it depends on which end you start with.
Yes. So I'm going to zoom in here to better illustrate what's going on here. I've started from this point and I drag out to the right and then come down, and you can see that it is adding that little dog leg, and the dog leg is progressively working towards the left. Now I overshoot because I need to reach to this point, and now it is doglegging down the other way. And depending on the the way this works in Fusion is that it will attempt to retain whatever you started with. So if, for example, I started by coming down and then across, it would end up looking exactly like you see here. If I started from here and came across and down, it would go out the other way. So we would end up with a segment coming out there and then down. Oh no, sorry, a segment coming up here and then it would come across, whichever way it is.
Try slash.
Yeah. So slash reverses it. Yeah, it would end up like that. So if I hit slash, it keeps alternating. The equivalent to slash in Fusion is a right click. So if I was here and I right clicked in here, it's going to bring up a menu. But it would do the same thing as being here and flipping.
While you're here, as long as you've got the dog leg going the right way, so move it off the pad there, and then press F for finish.
Oh, okay. So I'm going to move it up to, I'm just going to put it some random place up here, just for the fun of it. So I've got it up there.
Said control gives more control while routing.
Oh, okay. Thanks. I'll check that in a second, Scott. So I've moved it up there. I'm just going to press F, and it has finished routing. So it has put the track down to there. Now what you'll see is that it routed the whole thing, even though I already had the track up here, because I hadn't clicked anywhere yet. If I undo that, let's see if I click on here, bring it up to here, and I just click. So essentially it's set that part of the track in place. And now if I press F for finish, it has retained the part that I set in place, and then it has finished putting the track down from that point. Yeah, exactly. Well, a waypoint, that's a great way of putting it. So it's completing it from the point at which I had stopped laying down the track.
KiCAD can sometimes end with these little kinks and stuff. If you bring that back, I think it's Command Y. Yep. I'm filled with the urge to mouse over that little kink there and then do a drag.
Escape to get out of the route tool.
Yep.
And then click over that.
Yep.
Oh, no, sorry, click once to select and then drag it down.
Or a D.
Yeah, okay, and then it's snapped, which is good. So it's got this weird kink. As I bring it down, it gets closer to the point where you can see there it has jumped right there.
Yeah, it's Johnny.
To auto align. Yeah, and then
it's still trying to go,
preserve.
well, you must have meant something
Yes.
there, and I don't want to throw away what you've done.
Yeah. So if I now leave it like that and then select this again, it has now lost that association, which is good. This feels like intuitive behavior.
Behind the scenes, and we can see there's a little option on the, I think the third one from the bottom there says whether to paint tracks a solid or an outline of the segments.
Oh, down here?
Third from the bottom, I think.
Oh, that one?
Johnny Bergdahl has gifted 5 memberships.
Thanks, Johnny.
So if you now do an undo, yippee!
Russell Rainey has received a gifted membership from Johnny Bergdahl.
Yeah, what I was...
Ostrov has received a gifted membership from Johnny Bergdahl.
Cool.
David Howes has received a gifted membership from Johnny
I'm just going to
Bergdahl.
talk over that.
Yeah,
So-
so let's do an undo so we can
Simon
see that
has
little
received
kink
a gifted
there.
membership from Johnny Bergdahl.
Yeah.
As you drag it down,
Keith H has received a gifted membership from Johnny Bergdahl.
oh, it's interesting.
No, the rendering changes to solid mode. It's not showing that little split segment, but that's okay.
So if you have two tracks that are collinear, it'll merge them together when you stop the drag.
Yeah.
And because they're merged together, it loses that little wart that you put into it, and so it'll be nice.
Yeah, this is good. It's doing the right thing. I like that. All right, so go back to solid representation. Do you have a preference for a solid representation or outline view?
Generally, when I'm doing it, I do it in solid. When I'm cleaning up the board at the end, there are some tools that you can do that kind of remove some daggy tracks that are left over. For final cleanup, I'll do it to outline and look for things that are a bit odd. Sometimes, especially if you've got super thin tracks, you can end up with a track that's in the middle of a pad and is kind of otherwise an orphan. So,
Okay.
just kind of a bit of a cleanup like that.
Yep. All right. Yeah, well, this is a thing for a future. We'll get to DRC and that sort of thing. But does DRC catch things like a stub track that goes nowhere?
DRC won't, because your circuit will still work. But if you have a look under Tools or Inspect, up the top.
Tools?
Must be under Tools.
Yeah.
There's a cleanup tracks and wires.
Okay, clean up. Right, there. Remove unused pads, clean up graphics. Okay, cool. But that's something for future anyway. We haven't quite got to that point yet. Now, if I wanted to finish routing this board...
Thanks, Scott.
Oh, DRC does catch stub tracks. Yes, great, Scott.
Great, Scott.
Great, Scott. All right, so I'm going to route from here to here. Oh, it's not letting me. My guess is that is because the design rules are preventing this track. You can see that these pins are very close together on this transistor. Annoyingly close for a beginner to solder this. And because of the keep out rules around that track, it is preventing me from moving the track to intersect with the pad. So, we need to do something about that.
It's time to edit a footprint.
Yeah. Okay.
Okay. It is a can of worms, though.
Yeah, do we want to open that can of worms right now? Possibly not. Let's leave that for next time. And I know this is not really required for this particular board, but it's on basically every board I do, I have ground planes and power planes. So if I wanted to add a power plane, in fact, better still, let's add a, let's add a ground plane to the top of this PCB and see how I would go about that.
If you're doing a surface mount board, you would typically put the track on the same side as the components, otherwise you're not going to be able to put the components down and then put the ground plane on the back of the board. What do you want to, I mean, this is a through-hole design, what do you want to do?
Because I want to see, ultimately it's not going to stay on the board. What I want to see is the behavior of putting a ground plane down on the same side as the tracks and how it deals with spacings and flowing through gaps and those sorts of things.
Yep.
So let's put a ground plane on the front of this board just to see what happens.
Yep.
All right. Do I do that with a polygon tool, or what is the best way?
On the right hand side, you've got the list of kind of tools that you've got. About 6 down, that's the one.
Okay, so add a filled zone.
So the two options there is a filled zone, and then there's a keep out. So if there was an area, for example, where you had an antenna that you wanted to say, I don't want any copper here, or some physical thing where you don't want any copper, keep out is like an anti-zone.
Yes,
Okay,
nice.
so
positive space and negative space.
Filled zone.
Yep.
So
and then
click on I would recommend clicking on the top left-hand corner of where you want the zone to be, and it can be outside of the board boundary there.
Yep.
The first time you click there, a dialog will pop up.
Okay, now interestingly, because that is off the grid now, I can't select the corner of the board, so I'm going to select outside the board because I'm curious to see what happens.
Yep.
So I'm going to click there, we've got the dialog.
You can choose which layer it's on.
Yep, so we have front copper selected.
And also which net it's associated with.
Okay, so we don't have a net to associate this with at the moment. If, for example, I wanted to put a ground plane on and the net was just going to be called ground or GND, could I add it here at this point?
Yes, you'd go through the list of nets and pick GND.
Yeah, except that there is no net there.
Yep.
Yeah, Okay, so this is the filter for selecting out of here, but we don't have a ground. All right, so I'll just leave it as a an unnamed area for now.
Let's have a brief look at some of these options here. In order to have avoid solid areas all over your editing, there are two things here. It's whether or not the display on the screen is solid or hatched. It's set to hatched at the moment, but that's different to how it's actually going to be on the board when you finally do it.
Okay, so we've got line hatched or fully hatched. Yep. And pitch, so this is just visual. And then over here on fill type, my guess is this is how it would be in the copper when it actually creates it.
Yep.
Okay.
Clearance and minimum width says how close it'll get to, say, component pads, and how hard it'll try to fit between other things.
Okay, so if for just hypothetically we had, say, an 0603 surface mount resistor on here which had a small gap between its pads, these two numbers would dictate whether it would flow through under that resistor in terms of the spacing it needs to the pad and how thin it will make the pore that goes through. Is that correct?
Yes, that's right.
Great.
I'm looking at Scott's got a good idea here.
It won't fill without a net.
And then the next one there, for example, if we had a net label of ground, we could then select that. If we turn off that hide automatically generated net names, then we'll see one of them there has got a BT1 minus in it.
That one right there.
Yep.
So that is effectively our 0 volt reference or our ground. That's the negative battery terminal. So we could use that just for the sake of this exercise now.
So for the folks at home, if you have, so the two pins of the emitter pins of the transistor there are going to be connected to this ground plane. So if you've got a large ground plane there, you put the soldering iron, it's going to suck all the power out of all the heat out of your soldering iron. You're not going to be able to solder it. So the zone is modified when a pad is connected to the zone with these little things called thermal relief.
Yep, so we've got options here. We could turn off thermal reliefs entirely and make it solid, which would cause that problem Mitch was just referring to. Or we can have thermal reliefs generally, or thermal reliefs for... Well, actually, what's the difference between solid and none? My expectation is that, well, none would have no thermal relief, so it just has continuous copper
Might
core.
be that it's not connected, I don't know.
Yeah,
Well,
okay.
We'll see that another day.
All right.
You can set in general there general parameters for how thick the thermal relief spokes are and what the gap is between them. You can also then go and customize on a per footprint basis what the thermal relief stuff are, so you can customize that per footprint. But for the moment, I think we're just about ready to...
We'll just leave it as it is.
Yep.
One of the minor thing that I'll just point out here is the remove islands, always never below area limit. That is because sometimes if you have an area that is bounded by tracks, the question is, should you put an orphaned piece of copper in that middle area, which means that it won't be electrically connected to the rest of that polygon, or do you leave that area blank? Which my word-based description probably doesn't make much sense, but
I think
my default is to leave always, is to remove islands always. Yeah. Okay, so I
System
have...
notification. Stream is over.
Right.
So now I have this tool that I can use.
So that dialog came up with the first click. What we can then do is another succession of clicks in order to define the polygon.
All right, so I'm just going to make a bounding box around the entire PCB, and you can see that it, I was going to point with my hand, you can see the reddish coloured highlight area is the area that would be covered if I allowed it to complete the polygon at that point. So I am just going to draw all the way around here and go back to the starting point. Oh, interestingly, it didn't come up with the circle, but it completed anyway. So we now have a polygon that is slightly bigger than the PCB. I'm going to hit escape, so I'm out of that tool.
Okay, now there's a difference to defining the fill and getting it to calculate the fill.
Yes, doing a pour.
To do the pour, press B.
B for pour. Okay.
Mm-hmm.
And now we can see that it has filled in copper near the tracks, but not touching them.
Let's have a look at the transistor emitters.
And down here you can see that the pin has been connected using these little thermal relief lines. And this is what Mitch was talking about earlier with the thermal relief, where these are the spokes, and it's the thickness of the spokes and the spacing between them.
Interesting to see the modification of the spokes there, because we've set the clearance according to what the board house wants us to do. We've set the clearance to say keep copper no closer than this from a particular pad, so it's modified the little spoke there to keep it away from pad 2.
Yeah, you can see that there is nothing coming up
Just
here.
there, yeah.
Yeah.
Something else, if you right click on the edge of the zone, you'll need to zoom out for that.
Yep, so right click on the edge there.
Yep. Have a look under zones.
Where is zones? Oh, there.
Mm-hmm. If you're able to click right on the edge there, what you can do is set new control points there. So if you've put down a rectangle and then you need to stretch that in a particular direction, you can add those. I think we would need to click absolutely on the edge.
Mm-hmm. On the edge of that, I thought I had. Maybe I didn't.
It might be a grid thing, I don't know.
Yeah, it should be on grid because I snapped it to the grid when I was putting it down.
Oh, you can see it highlighted there, that might help.
Yeah. Okay, so if I right click on that and go to zones.
I'm not quite sure what's happening there.
No, okay.
There is a way of editing the boundary of the zone.
Mm-hmm. Yep. Okay, now the next thing I want to do is...
And we notice here we don't need a track going from the battery negative to the resistors there.
Right.
Because the current can flow through the copper for the zone, for the pore.
Yes. And you can see up here on the battery connector, the negative side has been joined in the same way. So effectively we have the equivalent of a track from the negative there to all of the points on the board that have a connection to that copper pore. Now, one thing that I want to see is we have the pore in place now. It's been filled, and if I
Scott Miller said right-click and chose Add Corner.
Add corner, okay. So I want to drag this track, and I've moved it now. So the track is in a new location, but it hasn't updated the pore. So if I now do B again, it's recalculated and updated that.
There are two other times when it will offer to do that re-pore for you. The first is when you run a DRC, and the second is when you generate Gerber files.
Right, okay. So Scott was saying right click and choose add corner. So I'm going to mouse over that edge of the polygon pore, right click, and
Create corner, there it is. It's not tucked into zones.
right, create corner. And it's now made a point right there. Interesting. So now if I just click on that and drag it, I can change the shape.
You can then create further corners so that you can make a rectangular. Yep.
Yeah, and the other thing is that it automatically unpored when that happens.
System
So
notification.
if I
Fever
press
is
B
angry.
again,
5
it'll
minutes
refill.
ago.
Now what this has also highlighted is that the pore has been restricted to the physical size of the board. Even though the polygon is bigger than the board, it protrudes beyond its borders. And conversely, if I move it over this way, so that it's overlapping diagonally, and then I pore again, you can see that it's being constrained to the edge of the polygon here, but it's also being constrained to the physical border, which means that if you want to do something like a ground plane across a board, all you have to do is make a polygon that's bigger than the board, and you've done the job. It doesn't have to exactly match the outlines, which is good.
So worth having a look at the 3D viewer.
Yes, I think that's probably, we'll look at that, and I think that's probably a good place to leave it. So what's the shortcut for getting to the 3D viewer from here?
Option 3.
Option, Where, option. I don't even have an option key. Maybe it's Alt 3? Alt 3. View. There we go. And I'm going to plug my space mouse in because I think it works in this. Maybe it doesn't. Maybe my space mouse is flat. Oh, I don't know. Anyway.
The light's on.
Yeah.
It might be something in the setup.
Yeah, so here we have the 3D view. I'm pretty sure I've used the space mouse previously.
Is the zone pulled back from the edge of the board?
Not in here. Let's regenerate this. So I'm going to drag this over to... Oh, also, the other thing I'm going to do is not pour this. And now, does this update live? Yes, it does. Well, when I switch back to it, it updated. So you can see that the copper has now gone from most of the PCB. And if I come back to here and press B to pour the copper, and then switch back to the 3D view, it's reappeared.
That update was on mouse over.
Yeah, it wasn't on the actual
You can set
B.
it to be live.
Yeah, so I'll move it back to there, and I'll, what is the unpour? I'll just move something, because that has the same effect. So I've unpoured it, and the 3D view hasn't updated, but if I just move my mouse over it, it immediately updated. But once again, if I do B in here, you can see that the, how do I do pan in this?
It's the deal. The deal here is that you press space when you're.
Oh, there we
So
go.
if you, yep. So there's that. You can also move the cursor over where you want your zoom point to be and press space,
Oh,
and that will center it.
right, okay. That's pretty cool.
Johnny Bergdahl said, check my comment.
What did Johnny say? He said, so don't do that. In case you wondered, we're doing a bit loony style 18-hour stream. I submitted a PCB to a Chinese manufacturer with a ground fill bigger than the board size. They contacted me to ask how big the board should be. So don't do that. Interesting.
How did that come through? Was it Gerbers? Because the Gerbers wouldn't show the zone.
They shouldn't. That is odd. Although I actually had an issue with JLC. I think they changed the way their import process works a little while ago. This is maybe 6 months ago. I had a board with a large connector, and on my what was it? I can't remember which layer it was. It might have been the silkscreen layer. What I did was I had a connector and moved it so that it was it was overlapping partly off the board just because of space constraints, and the silkscreen came outside the boundary of the board. And when I uploaded it, they calculated the board size based on the bounding box, including the silkscreen.
No.
So I ended up editing the footprint to remove the silkscreen from that part of it, and then re-uploaded it, and it worked. So there can be weird things like that happen.
I reckon we tidy up this zone here and put it to bed.
Yes, I think so too. All right, so back to here.
Why have we got air wires there?
Because they haven't been routed yet.
Yes, because of the clearance issue.
Yes.
I suggest next time we take this as an opportunity to do some footprint editing and lay out those paths as a triangle rather than inline.
Yep. Okay, so I've just squared up the...
Nice.
that again. And just because I can, I'm going to make this a little bit tighter. The actual board size we will need to fix. Oh, it's
Yeah, because it's not a rectangle, it's segments.
yes.
You're in a world of pain there.
Yeah, I am. So this is something that can be fixed up next time.
What I would do is an undo.
Yep. A few undos. Back to there.
Yep, I would then click on that bottom thing.
On that.
Yep,
And then do
M and use the keyboard.
M for move, and then
use the arrows.
use the up arrow.
Press enter.
But what that has not done is move the sides.
Yep. But then it'll snap to if you move that.
Yep, so if I drag that, it'll snap to there. Right. So with the polygon, does that behave the same way, or can I
Scott
drag
Miller
it
said,
like that?
John, for
Yep.
the
Oh, that's
lines,
better.
Use move. For the polygon, drag the center spot.
Yippee!
Yep. Hey, thanks, Scott. Yeah, okay. And Command 0, I think, makes it fit. Is that right? Yes, it does. And then, was it, which way? B for filling the copper. Okay, so now we have a closer representation. I don't like the way these tracks go. This was just me quickly clicking things around, but we can fix all of that next time.
We have the technology.
Yes, so now I can do save, and back to here, it's updated the view, and we have a board. I wonder what Command 0 does in the 3D view. Does it make it fit? It does.
We should at some stage verify that these components are actually the size that we want. We really just pulled them out of a list.
That's right. There was, yeah, it was whatever was the default basic through-hole
Looks about
parts.
right.
Yeah.
And then you get the board and yeah.
Yep. So this is where you would do a paper fit.
Absolutely.
Print it out, one-to-one scale, and put the
Folks,
parts on
always
it.
do your fit test.
Scott
Yes.
Miller said, which episode will John learn to round the board corners?
Yeah.
There's an art to that.
An art to it.
Yes.
There's a fillet tool in Fusion, so all you do is click the corner and it turns it into a rounded edge.
I think KiCAD doesn't have one yet.
Yeah. That's actually been one of the really nice things about Eagle becoming part of Fusion, is that it has inherited a whole lot of really nice 3D, mechanical CAD tools.
Is E204 a food additive?
I think rounding corner is E204, episode 204.
Oh.
Okay, just make the whole board round. Yeah, says Stephen. We should, because the original design was kind of made to be so that you could cut it to be round. If you look at the original board layout, if I come to here, I wonder if there is a better view of the board layout in this. The whole thing.
I didn't pick up on that. I'm looking at the picture of the lass on the front page.
It was fitted into a circle. So if we come back to here, she's wearing a flashing LED necklace, and it's a circle. So somewhere back here, there we go. Here's the board layout. So this is the artwork for the original board layout. And it was all done to fit inside a circle. And then it was just put on a rectangle so that the rectangle could slide into a jiffy box or a
To
zippy
make
box.
it cheaper for them to produce, they rely on you to cut it to a circle.
Yeah, because they didn't have automated board routers and things at the time. By router, I mean like a thing that a milling machine. Yeah, a machine that physically cuts the board to a circle.
Johnny Bergdahl said, "Oh, that is a pretty PCB."
This one, yeah, that's pretty cool. Look at all the nice curves in it.
Coming in episode 301 is how to get KiCAD to do nice curved tracks like that.
Yes.
System notification. Peter is super angry.
Sorry folks, I touched the mic.
Okay. Well, amazingly, we got tracks down.
We
So-
didn't get sidetracked.
Didn't
too
get
badly.
sidetracked, no. We got sidetracked a little bit.
Thanks for sticking with us, folks.
Yeah. Now, I think my brain is pretty much empty. It was empty before it started. I'm drained. Okay, so Mitch is not going to be here next week, sadly, so it's not going to be 4 continuous weeks of the John and Mitch show. But perhaps sometime in the future you can come back and we can continue with this. Next week, I have no idea what I'm going to talk about, but there'll be something.
Squirrels.
And, KiCAD has a curved track plugin, says Wagon Loads. Oh, and Iggy says, but they're on the wrong side. Yeah, we have tracks that are on the wrong side. We can change
John
that.
and I talked that one thing we want to do is show Yols how to switch the tracks to the other side.
Yeah, so we will do that next time. Right, so I think that is about it for today. I feel like I need to go and fall over in a heap somewhere. All right, Season 3, Episode 12, JLC Deliver the PCB.
Have a fantastic week, folks.
Yes, and I will talk to you all soon.
Go make something.
Bye.